Alright. Okay, so allow me to walk na lang. Since I'm short, baka hindi niyo ako makita pagdanda sa podium. Alright, so yeah, thank you for having me. So this is the title of my talk. And just to set the expectation, this talk will not be very technical, so it's just going to be a high level. And I'm going to put it in the context of Python developer. Okay. Again, here are my credentials. So those are my handle. Okay. So I'm currently working as mentioned earlier, as an ML engineer at OpenSolar. So it's an Australian-based software solar company. Okay. So here's the outline of my presentation. Okay. So what is energy? Energy development pipeline, developing software in energy, cool things that you can build, and of course, final thoughts. Okay, so when we think about energy, this is just the simplest equation, right? It's just energy is equal to power in watts, and you have your time. But energy is a critical infrastructure. If you're going to listen, if you have listened in the previous keynote, wherein he identified that energy is one of the infrastructure, and it powers your artificial intelligence, your robotics, your data science, and everything else. So if without energy, we're not able to build anything, right? So the question is, what are the various types of energy? And it can be classified into two ways. You have renewable and non-renewable. We know the non-renewable, you have the oil, the gas, and so on, and you have your renewable energy. And if you're going to try to decompose renewable energy, you have all of these components, right? So in the Philippines, we already have majority of these types of renewable energy, except for ocean renewable. It's still an emerging technology. So I had the project before, back in 2014, wherein we identified what are the areas where we can develop and build ocean renewable plants. And we have identified that, okay, in the Philippines, you have a lot of sites which have the potential to be developed. But it's still an emerging technology because it has a lot of cost and, of course, R&D. Now, when we think about energy, right, so these lights, the microphone, what's being charged right now, this is the simplest diagram that we can think of. You have your power plant, you have your distributors, in this case, Meralco, for example. Okay. All right. Okay, so you have your Meralco, then it will be connected to this residential space. But in reality, it's very complex. You have all of these interconnectivity between your supply chain, where do you import your solar panels, where do you create the permits, where do you handle the connection, the right of way, and how the market will respond to the energy. So if we're going to decompose it, these are the various steps in developing an energy power plant and putting it into operations. This is, again, a very simplified diagram, but it will tell you the high-level steps. And I've established, or I've been in some companies who did the end-to-end of this. And it's very hard and it's very expensive. So for example, in oil and gas exploration, it will cost about $1 million just for 1 week of exploration. It's not even operations. Then if you multiply that, let's say you do it in 4 weeks, you're having, let's say, 4 million, right? $4 million. Just for 1 point. And in the Philippines, when we're going to decompose it into more permits, these are the various things that we need to create. And you're going to interact with all of these agencies. So in the Philippines, we have the Energy Virtual One-Stop Shop, wherein it has all of the forms, all of the things that you need to submit to the government. So for example, you need to have a sample map, you have your template for NGA's or LGU's endorsement, wherein before you build a power plant, you need to ask the local government unit, where can we build? And you need to ask for, the people to have support because you cannot just build a power plant without community support. So if we're going to try to think about it, how can a Python developer like you, or you're aspiring to be a Python developer, impact an energy company? So as a technical person, you're going to go into a Python or into an energy company, and you're going to have certain assumptions. Maybe we should create an API. Maybe we should create a data warehouse. Maybe we should create a standard form, all of these. But what are the end users or the people who will consume your solution think, right? And most of the time, when you're going to talk to the domain experts, the geoscientists, the solar engineers, their requirement is very simple. The requirement is that you're going to have, let's say, I just want to have a CSV of data. Sorry. Right? So you can just put it into a spreadsheet. And that's what they need. That's all what they want. They don't need a SQL database. They don't need a data warehouse wherein they can query. Because the requirement of a end user or of a geoscientist or, let's say, a domain expert is very simple. But your job is actually to understand their requirement and put it into and integrate it into the infrastructure of the organization. So this is where Python comes in. So what actually happens, again, these are all the various things that you're going to encounter when you go into the energy company, wherein you're going to be exposed to math. Again, the math may not be as simple as the sum or mean or average or statistical equations, but they are physical equations. So if you went to the talk earlier about the MANIM visualization, you're going to see those formulas. Finite elements, let's say you're going to see fast Fourier transforms. Those will be exposed when you're developing inside an energy company. So something that is very crucial as well is that I want to highlight here that it should make sense with the science. A lot of times as software developers, we think of let's apply solid principle. Let's apply the various things that we can abstract, right? We build abstraction upon abstraction. But at the end of the day, what they just want is just one point, a decimal or a location of such values. And we tend to lose focus on the requirement that we build all of these big infrastructure such that we tend to lose our end users here. Okay, so in solving the energy, some problems in this space, you're going to encounter with very legacy systems and very old data. When I say old, it's very old. One project that I encountered, I was working with a 1960s data, wherein the data is in raw format, is in PDF, it's not even in PDF file, but it's in actual shelves of these companies, wherein you need to take a picture or scan them and implement some sort of OCR or an ETL pipeline. And these things are very, very mundane, but they actually have an impact when developing an energy resource. And of course, you're going to encounter with very legacy systems. So I had a project before wherein the project, we need to develop an application wherein it should work with Internet Explorer 9. Wherein, okay, because the company was a national oil company before, wherein they interact with Microsoft and told them, please support our application. And of course, it was based on Internet Explorer 9. So when we're going to think about it, since the talk is about, or the theme is about Haligi or pillars, we're going to think of it as Python as foundation to work with energy. As I've mentioned before, domain experts, domain scientists are already very tired, or they're already flooded with all of these complexity, the equations, the various, the nuances of the job, wherein they don't need additional layers of abstraction. So the simpler the solution, the better. And Python provides that. It provides that readability, that accessibility, that portability, right? So I really like, I think I forgot the speaker, wherein I went to, I think this is also true. I went to, or I had a client in, I think, Middle East, wherein their data center doesn't have any internet, internet connectivity, and the only installed version there is Python, I think 3.6, wherein you're not allowed to install, pip install anything, so you need to use the standard library, and sometimes you need to do this via remote, and you don't have access to the remote server, and you need to call them via Skype, and you do this tech support. And it becomes very mundane, but it's very rewarding because imagine if you're able to develop or identify an energy resource and deploy it, you're going to impact more people, and you're going to impact even the economy of that place. So in the energy space, you have your, let's say, domain-specific tools, and you have your data science stack. And most of the time, these are the only things that you need. You just need to combine something that's going to read the data, and you combine it with the data science stack of your choosing, from Pandas, from NumPy, from your Torch, or PyTorch, and all of these. And it's already enough, right? So I'm now going to go into some use cases, what you can do as an impact. Okay, so these are just general use cases, and they are, they are very targeted to what I did. Again, the library actually doesn't matter. What matters here are the use cases, and most of the time, I can put them into these themes. So in the first theme is, of course, you're going to do some data mining. So again, I've mentioned earlier about working with obscure data and very old data. Then you put it into some CLI, some script, some ETL pipeline, and you're going to put them into a database. Yes, in the energy space, Excels and spreadsheets are databases. And again, these are easy to work with because, again, domain experts, they don't have the time to learn SQL. They need to look, okay, it's very, what we call, graphical user, and you just highlight the data that you need to work on. Then you're going, and sometimes you're going to build data platforms. So again, you have your model, right? This is built by your domain side or domain experts. And you're going to package it. I really like Django because it has this admin interface already. You don't need to rebuild everything from scratch. Then you just package it, and you have your NumPy arrays to work with image data if you are into satellite imagery or some, let's say, time series table. You can work with NumPy. Then you visualize it, right? At the end of the day, what really matters for the domain side or energy people would be just dashboard. The internal processes doesn't matter as long as the model or algorithm provides a correct output. Okay. So this is what, so this is just a plug from my company. But so essentially, since I'm working with Open Solar now, so what happens here is that, let me turn off the audio. Sorry. Oops. Okay. Apologies. Okay. Okay. So what happens here is that you have, let's say, a Python. So we've built a design software wherein you can place your solar panels on top of your rooftops, and you're able to identify how much energy that you get. And from this, you'll be able to select the type of solar panel, and it does its computation behind the scenes. And the tech stack for this is just Django, and you're just playing around with, it's doing all of this number crunching behind the scenes. Because what happens here, before you can place a solar panel, you need to understand how high is the building, what is the slope, what's the azimuth, all of these. And everything is powered by Python behind the scenes. And most of the time, this already works, right? So, and it can be quality checked by the domain expert who is actually focused in energy, wherein does the energy output of those solar panels correct. So as you can see here, you have the energy output of this solar panel design. You're able to detect, at least for a time scale, and even that the period or time, how much energy in per kilowatt will you get. Okay, so this is already my three slides left. So what skills should I develop? I've come from a geomatics background, and I've already had some idea about geospatial solutions, how to work with satellite imagery, GIS, so on. And I've developed my Python skills by going to a startup, a research project, then a startup for about 6 years. Then I went to Open Solar. And most of the time, you're going to have this deep expertise. As a start, you're going to have deep expertise already in terms of software development, in terms of algorithm design. What you want to develop on are the broad skills or general skills. So in the energy space, you're going to learn, okay, how does the energy ecosystem work? And most of the time, you're going to be daunted at first. So I had an onboarding with a new hire. The feedback that I got from him is that it's very daunting because he is a full stack developer already for 9 years, 10 years. If you're going to think about it, that's already very senior, right? But when he came to the energy company, okay, all of those things does matter, but now the jargons come in, the science comes in, and he is now forced to learn those things. Now, you should not stop at the T shape, be a comb shape. You should not go just the letter T only with broad knowledge and just one specialized. Now, because of the advent of artificial intelligence, you need to upskill. Similar in the energy space. I think in the introduction, I was introduced as working with ocean renewable. In my previous work, I was working with the oil and gas industry. Now I'm working with the solar industry. So in all of these pillars, or let's say spikes or teeth, right? You're now going to grow beyond what you have initially learned, which is for me, I am a geomatics engineer, GIS. Now I'm on this full multifaceted system, or let's say developer, because once you have a good understanding of how those pillars work in terms of, let's say, energy, you're able to capture and package yourself, and you're able to solve any problem in this case. So, yeah, so I'm just going to leave this final slide here. So this is the S-curve. It was just recently published, I think, a month ago, wherein by 2036, there's a projection that 50% of energy production or consumption will be powered by solar. So there's still going to be traditional sources of energy from oil and gas, from other renewables, but everything will be, 50% of it will be powered by solar because it's cheaper, it's easy to deploy, you don't need big turbines and so on. It's now going to be a more decentralized way of thinking because you can now put your solar panels on top, right? You don't need, let's say, a Meralco in the distribution scheme. But for utility scale, wherein you need to have, let's say, power manufacturing plant, maybe those are the only industries that will now be covered by, let's say, your NGCPs, right? You're offloading the work from, let's say, a monolithic architecture. It now becomes a microservice type, which is what we're trying to, what this graph represents. And for that, again, these are my credentials. If you want to talk specific for anything more specific into energy, right? So you can just chat me up because there's a lot of, I would say, complexity in energy. So I'm not going to dive into that because this talk is targeted for beginners, actually. So it's just provide you an avenue wherein you can make an impact. Because I think a lot of us here for Python, or let's say software developers in general, we want to make an impact immediately. If you want to make an impact, maybe work with energy, and it will have an impact already. And with that, that's it. Okay, so that's the end of my talk. Thank you. So I think questions, I'm free for questions.
Thank you so much, Sir Ian. Like what Sir Ian said, we are now entertaining questions. So if you have any questions, feel free to go to our aisles and use our microphones to ask.
Hi, Ian. Thanks for the energetic talk.
Energetic.
Just a question about on the technical aspects, specific to the energy domain. So you work with the upstream side of the energy domain. I'm curious of the nature of the data that you deal with. Is it what's the scale or volume? Do you reach big data levels? And also, is there real-time data?
Okay. So when I first went into energy, there is that term called big data, right? The term of big data comes from, okay, there's a lot of volume. How I'll say for energy, it's very dense data. One file will give you 1 terabyte. And the spatial resolution may be 100 meters by 100 meters. Now, if you're going to look at it on a macro scale, you're going to encounter more data like that. So in terms of data itself, it's just going to be one image, but that one image is 1 terabyte because it contains a lot. So I'm going to say it's more of a dense data. So the question, what's the other question? Sorry.
How about the frequency?
Frequency. So it really depends on the industry. So in the Philippines, sadly, we don't have very rich data sets. It's partly, again, there's a lot of factors behind them. But if you're going to look at it, I mean, what's published right now is just 1 km by 1 km. 1 kilometer by 1 kilometer by spatial resolution. So let's say one image, 1 pixel is only good as 1 km by 1 km. Sometimes it's good for pre-feasibility studies. But if you're going to do micro, it's not anymore good. So you need to fly drones to it. You need to do surveys, which I did back then, wherein I stayed in front of, let's say, I think a lake, and I slept there for, I think, 24 hours. They're just monitoring the instrument, getting data. So the frequency, it varies on the energy type. So for solar, it's, I think, in the Philippines, it's a little bit bad, right? Because we don't have data rich. But let's say in Australia, in US, they can compute the data. So for example, the app that I showed earlier, the frequency that the data there is about 0.1 meter. It's already enough. It's even less than this length, right? But that's the resolution that you can get.
Sounds really challenging, but really exciting. Just a quick follow through with that. So, is Python, as part of your toolkit, does it solve the majority of those problems?
It solves actually all in this case. Because as mentioned earlier, you want to make it simple. Python provides that simplicity. Because at the end of the day, if you're going to create code, right, from the algorithm of the domain, you're also going to give it back to them. And they should be able to read those. If you're going to build a lot of abstractions, it's going to be a little bit nuanced in this case.
Thank you very much. Energy is so exciting.
Hi, I have a question. Sorry. How would you suggest someone who has no experience in the energy field, if they're like interested in getting into it, how would you suggest like stepping into it? Even on like a volunteer basis, obviously you can't just get a job right away, right?
Yeah. One thing that usually happens is that DOE, Department of Energy, publishes a lot of reports. And all of these reports are in PDF files. And they're not searchable. They're very hard to search. One thing that can be done is create maybe just a bunch of CSVs that's already parsed all of these data and just publish them, even if it's just a Git repo. The barrier of entry is very low actually. Because the usual automation stuff that we are doing, just apply it on the different data set, which is energy. And that's it. And put it into the Philippine setting, then you're going to have a more robust ecosystem in this case.
Hello. So you mentioned earlier that you worked with really old files, like physical files. And so I was wondering if there are cases of data loss, and did that pose a challenge, or how did you solve that?
Yeah. Back in, I'm not going to say the government agency who handled that data, but they have data which came from the 1960s, as I mentioned, and and it was stored in magnetic tapes. If you're not familiar with magnetic tapes, they're very old, and the only instrument that can read to this day is only one instrument left. And a lot of these data are already deteriorating because the room that was stored is not, you know, environmentally proper for data storage. And sadly, there's no way to bring back those data. And the only way that you can do maybe there is implement some ML, some linear regression to backtrace all of these data points. But at the end, it's nothing that you can do already because these data are already gone.
Thank you so much. Do we have any more questions? Okay, we have one more question.
Can I ask what are the different ways or the different use cases of ML in your work? Can you cite specific examples?
So machine learning?
Yeah.
Okay. So one thing that I have encountered is that plant maintenance. So for example, solar farms, right? You have solar farms. And it has what we call a lifespan for those solar panels, the wiring, the batteries. And some companies are attaching sensors to monitor temperature, to monitor other things, right? And it's put into the ML model wherein they're able to identify, okay, this solar panel, this group is going to die in 2 weeks. Then you're going to inform, let's say ERC, or that we need to schedule a downtime because that part is going to go, it's going to get caught fire, right? So you want to implement preventive maintenance. That's one specific. And in terms of general use cases, in terms of one thing that I've encountered as well is that when you're building, let's say, the roof panels or you're trying to identify where can I place these solar panels without data. So you're only given, let's say, RGB. How can you place those panels? Because you need to check the DSM or the elevation. This one, you need to predict those. And yeah, those are two. If you want more, I can specific.